Hey everyone, and welcome. Today, we're going on a little something I like to call a vector quest. We're going to take a classic math problem and break it down step by step. But first, let's talk about something cool. Ever wonder how in your favorite video game, a character's shield can just perfectly block an attack? Like, no matter what angle it comes from? Well, that's not magic. It's all math. And believe it or not, the math that makes that kind of precision possible is exactly what we're going to tackle today. So let's get right to our challenge. All right, here it is, our official quest for today. We need to find a unit vector, that's a key word, a unit vector that's positioned exactly 45 degrees away from our starting vector, v, which is 4i plus 3j. Now, this might look a little intimidating at first glance, but don't worry, we've got a super simple three-step game plan. First, we'll find the angle of our starting vector, v. Then, we'll calculate the two target angles we're aiming for. And finally, we'll build our brand new unit vectors from those angles. Easy enough, right? Let's get started. Okay, on to step one, finding the angle of v. You know, before we can figure out where we're going, we have to know exactly where we're starting from, right? So let's lock in the angle of the vector they gave us. So our vector is v equals 4i plus 3j. What does that actually mean? Well, think of it just like directions on a map. That I part, that's our horizontal move, so 4 units to the right. And the j part is our vertical move, 3 units up. If you picture it, it's just an arrow starting at the origin and pointing right to the coordinate 4, 3. So how do we get the exact angle of that arrow? We're going to call that angle theta, and to find it, we just need a little bit of basic trig. The key here is the arctangent function. See, it's perfectly designed to find an angle when you already know the opposite and adjacent sides of a right triangle, which is exactly what our vector's components create. So the formula is really simple. All we do is take the vertical part, that y value of 3, and we divide it by the horizontal part, our x value of 4. Then we just pop that fraction into the arctangent function. Go ahead and punch that into a calculator and voila! You get our starting angle about 36.87 degrees. And just like that, we know the exact direction our original vector v is pointing. Step 1, done. All right, now for step 2, calculating our target angles. We've got our starting point locked in. The problem asks for a vector that's 45 degrees times away from it, so let's figure out what those new directions are. So, 45 degrees away. That phrase actually gives us a clue. It means there are two possibilities, right? We can either add 45 degrees to find one direction, or we can subtract 45 degrees to find the other. So let's do it. First, we add 45 to our original angle, which gives us 81.87 degrees. Then we subtract 45, which gets us to negative 8.13 degrees. And by the way, don't let that negative sign scare you. A negative angle just means we measure it clockwise instead of counterclockwise. Simple as that. Perfect. We have our two target angles. We're on the home stretch now. Let's move on to our final step, actually building the unit vectors. This is where we put it all together and get our final answers. But hold on, quick timeout. What exactly is a unit vector again? Think of it this way. A unit vector is all about pure direction. It always has a length of exactly 1. Its only job is to point the way without adding any extra length or magnitude. And lucky for us, there's a super handy formula to build one. To create a unit vector from any angle, the horizontal I part is just the cosine of that angle, and the vertical j part is the sine of that same angle. That's the recipe. So let's take our first target angle, that 81.87 degrees, and plug it in. The cosine of 81.87 degrees gives us our I component, which is about 0.141. Then the sine of that same angle gives us our j component, which comes out to about 0.990. And there you have it. We just combine those two pieces, and we get our first solution. The unit vector u1 is approximately 0.141i plus 0.990j. Awesome! One answer down, one to go. Now we just rinse and repeat. We do the exact same process for our second angle, negative 8.13 degrees. The cosine of that gives us the I component, about 0.990, and the sine gives us the j component. And notice, this time it's a negative value, about negative 0.141. And that gives us our second and final solution. The unit vector, u2, is about 0.990i minus 0.141j. And with that, our vector quest is complete. We found both answers. So, let's bring this all the way back to that video game shield we talked about at the beginning. The game's code can now use these two vectors we just found to define the exact angles that shield needs to be at to perfectly block an incoming attack. Pretty cool, right? All of that precision comes right from this kind of math. Okay, now that you've seen the whole process, you know the best way to really make this stuff stick is to try it for yourself. So it's your turn to go on a little vector quest. Here's your first challenge. Find a unit vector that makes an angle of 60 degrees with the vector v equals 5i plus 12j. The steps are exactly the same as what we just did. Go ahead and pause here, run through our 3-step game plan, and see what you get. And hey, if you're up for a bonus round, try this one. Find a unit vector that's at a 90-degree angle to the vector v equals I plus j. Quick tip, remember, when you don't see a number in front of I or j, the value is just 1. This one's a great little check to make sure you've got it down. And as we wrap this up, I'll leave you with a final question to chew on. We started with gaming, but where else is this exact math quietly running the show? I mean, think about robotics, or aviation, or even physics. From plotting a pilot's flight path to programming a robot's arm, our entire world is built on these kinds of precise vector calculations. Thanks so much for joining me on this quest, and I'll catch you on the next one.